Yes, so my name is Bram. I sometimes blog, I sometimes tweet, and I sometimes steal titles for my talks. So, that's a good start. So obviously this title is taken from Fred's book, Learn You Some Erlang, and I had to come up with a title real quick, so this is what I picked. But I think it's actually a nice reminder for those of us in the Elixir world to not live in a bubble. I mean, if you're only ever calling Elixir APIs, only using the Elixir standard library, you're missing out on a lot of value there is beyond Elixir, and in particular in Erlang and the Erlang standard library. So if you haven't already, read Fred's book, Learn You Some Erlang, and then dive into the Erlang standard library. There are a few real gems there. And we're going to talk about one of them. And it's the SSL application, which implements the TLS protocol. Now, I'm sure we can all agree that the TLS protocol is very important. I'm sure most of you build networked applications that can be a client or a server or both. And TLS is perhaps the primary protocol for securing such connections. For many higher level protocols, it's the only standardized option. And specifically on Erlang, it's important to understand how the SSL application works, because if you're coming from another language where basically the TLS sockets are implemented by calling into OpenSSL, you might be surprised at the behavior of the SSL application, because it's basically an independent implementation of the TLS protocol. So it does depend on OpenSSL for the purpose of the lower level crypto, but the protocol state machine, the message handling, the certificate handling, it's all implemented in Erlang, and therefore your expectations coming from a more traditional OpenSSL implementation might not always hold. So what I want to explore today is what do you need to know in order to use this securely? I'm going to start talking about clients, and I'm going to talk about clients in general. I'm going to use a HTTP client as an example, just to be able to present some more hands-on code examples, but keep in mind that this applies to any SSL client, basically, any TLS client. We should try to use TLS to refer to the protocol and SSL to refer to the module or the application. So the HTTP client that we'll be using is the one that comes with the Erlang OTP standard library. It's called httpc, and it's part of the inetS application. So the first thing to know when you're using applications that are part of the Erlang OTP release standard package is you need to start these applications explicitly. If you don't start them, you'll get weird errors. So both inetS and the SSL application need to be started. And then we can make a call to an HTTPS URL. Now, in a project, you would normally put this in your mix file. This ensures both that the applications will be started as part of your application, but also that they will be included in a release. Again, otherwise you will get those weird error messages when you try to start your release. Okay, back to actually making an HTTPS request. I'm using a slightly longer syntax here, because later we're going to want to plug in SSL options to play with. So here you see a request to a valid HTTPS server, a legitimate server that presents a legitimate certificate, and the connection succeeds, so that's good. But if we make a request instead to a server that presents a self-signed certificate, this request should fail, but it doesn't. It fails to fail. I mean, we want this connection to fail. And this is very important because obviously when we pass in an HTTPS URL, we expect certain properties from the connection that the TLS connection is supposed to provide. And we're basically giving up on confidentiality, authenticity, and integrity. Now, we're getting a bit of confidentiality, right? Because a passive observer on the network will not be able to decode the messages. But an active attacker can basically compromise the connection in all these ways. And it's not just about confidentiality. I mean, it's probably the thing people look for most in TLS. It's protecting maybe API credentials or other credentials, sensitive user data. But authenticity and integrity can be very important too. For example, imagine you're creating a mixed task to pull the hex public key from the hex server, so https hex.pm/docs/public key. That's where the hex public key resides that is used to verify the contents of a hex package, the signature on the hex package. If you're retrieving that public key over a connection that's not authenticated and not integrity protected, who knows what public key you're actually retrieving? And if someone manages to inject their own public key, then your package verification will no longer be, you can no longer trust it. People might actually achieve code execution on your laptop. So that's a whole different topic, supply chain attacks on Hex. I have a blog post about that, so if you're interested, you may want to check that out. But the point is, we want to get all of these properties of a TLS connection. So what's missing is, well, before I explain what's missing, it's important that you test these expectations. Like, we were expecting this connection to fail. And there are test endpoints that can help you. So badssl.com is very useful. It does require an internet connection. So if you want to integrate something into your build environment, you may not want to rely on an internet connection or some external server that you don't control. But it's very, very useful because it allows you to test that connections that shouldn't work do in fact fail. Now, for those of you who want to run your test offline, so there is, I've created a package called X509. It does a couple of things, but one of the things it does is that it has a built-in test suite that covers some of the most important of those test cases that badssl.com also supports, but you can use it offline. So it doesn't have any internet, it doesn't require an internet connection, it doesn't require any external processes, no OpenSSL CLI calls or anything. You can run it within your unit tests and test the negative cases of your TLS client. Okay, if you want to learn more about this, talk to me later. Now, what is missing? So what do we need to do in order to make that HTTPC request fail as it should? So the important thing here is this part. Verify peer. That's the default for the verify option in the OTP SSL application is verify none. It means the client will start TLS handshake with the server will present its certificate to the client, and the client will just hand it to the garbage collector. So verify peer tells the SSL application, verify the server certificate before you actually complete the TLS handshake and start and hand the connection to my application. Now, you may be surprised that actually we're getting a 200 OK. So, I might be surprised too. I might be thinking about it for a minute. I might try again. And the exact same request fails. What's going on here? Okay, well, to understand what happened, we have to actually look a little deeper into the successful request case and look at the request headers or the response headers and notice that this is HTTP 1.1 connection, and connection keep alive will basically keep that connection open for subsequent requests. So this is something HTTP specific or HTTP client specific. Some clients may not support this, but it's something to keep in mind as you're playing with these SSL options. Don't get bitten by this, because it can be really, really confusing if you're saying, hey, I just changed my SSL settings, so why am I not getting this error? So the solution here, of course, is to pass an additional header in the request that forces the connection to close every single time. So if we're passing the additional header option, now every single time we make this request, the connection will fail, which is good. At least we have some consistency. Now, the error that we're getting is, it indicates that we did not pass in the CA cert file option. The CA cert file option should point to a CA trust store. And Erlang is telling us, if you don't tell me which CA certificates to trust, I cannot do verify peer. Now, let's do test-driven development. We're going to make the smallest change we can get away with to get past this error. Okay, so I'm just passing in CA cert file /dev/null. This is basically an empty file, but I'm now passing in the option, right? So I should get a different error. Well, in fact, I don't get any error. I get a successful connection. What happened this time? Well, in this case, we need to look a little bit deeper into the protocol stack and look at the TLS layer. So TLS has this feature called session resumption, which in production is a very powerful feature because it saves on TLS handshakes. Basically, the way it works is if a client and a server had previously communicated and established a successful TLS connection, they can both cache the TLS connection parameters, and on subsequent connections, the client can tell the server, hey, remember this connection with this connection ID? Can we continue where we left off? If the server agrees, then there's no TLS handshake. There's no server certificate being sent. The certificates are not evaluated. And it means also that the TLS, the SSL options that I passed in are not really used. So if I make changes to the certificate, like the logic that decides which certificate I want to accept or not, it's all ignored because we're just resuming a connection that was previously established. So for the purpose of testing, I mean, in production, you should definitely use reuse sessions true, which is the default. But if you're testing, it can be really confusing, just like previously with the HTTP connection keep alive. You want to have a deterministic behavior. So reuse session false will ensure that you won't get bitten by this. And you know what I see is people are struggling with these kind of things and this kind of inconsistent behavior, because if you're doing it as a unit test and you forget to pass reuse sessions false, then depending on the order in which your tests execute, some of your negative tests will actually succeed. And it can be really confusing, and then people give up and they just go back to verify none and basically giving up on the security. So I want to really spell this out because it's important to get get these things. Surprises are always bad because people throw up their hands and move on to something else. So we need to pass reuse sessions false, and now the connection actually does fail. Now the problem, of course, is that the connection fails every single time with a bad certificate, because remember our CA sort file is set to /dev/null. So now we need to talk about CA certificates and where do we get our CA certificate trust store. So the CA trust store basically tells the client which CA certificates are trusted. And there are a couple of options. Now, there's no CA trust store included in Erlang OTP release. It's something you need to bring your own. Now, you can bring one as a... most operating systems have a CA trust store built in, but Erlang is like too operating system agnostic to pick it up from on Windows and Linux and Mac. And so there are basically two packages in Hex that people tend to use. One is called Certify. It's the most popular one, and the new one, CA Store by Eric. It's the new kid on the block. But I want to go back to talking about the OS trust store, because maybe that's the best option. If you're using a package, a Hex package, you have to, first of all, trust the maintainer of that Hex package, that they will update the CA trust store when, for example, a certificate authority was compromised and their certificate needs to be removed, because root certificates cannot be revoked using the same mechanisms that other end certificates would normally be revoked. So if a root certificate is no longer trusted, you need to remove it from your CA trust store. So you need to trust someone to actually keep the package up to date. You then need to monitor Hex or GitHub to make sure you're aware of changes. And then when you actually want to deploy the change, you need to build and test and deploy a release, because it's packaged inside your release. You can't just go and dig into somewhere, some directory on your deployment server and change a couple of files around. If you're using the OS trust store, you just need to figure out where it lives. And in order to update it, you just need to install operating system package updates, which you probably need to do anyway, right? There are a lot of other packages that need to be updated for security reasons as well. There is no step 2. You don't need to restart your application. The SSL application will automatically pick up the changes. Okay, so I'm not telling you what you need to do, use this option or that option. But for the purpose of this presentation, we're going to use the CA trust store of the operating system, which lives in etc SSL certs on this particular machine where I ran this test, or where I ran this code. And now you can see that the connection to the self-signed server is failing, as it should. So here's the CA set file, and the connection to a legitimate server it succeeds because the certificate is trusted. It can be traced back to the CA certificate in the trust store. But there are still servers that fail to connect. And the error message here, I'm showing here error message from OTP 21.2. In 21.3 they were improved a little bit. Also in 22. So in older versions you may have to check the logs in order to get a little bit more information. So the generic alert is handshake failure, but that's not telling me enough really. The actual error is here. Hostname check failed. Okay, so the host that we're connecting to is one of the bad SSL.com test endpoints, and let's have a look at the certificate to find out what's special about this certificate. It turns out it's a wildcard certificate. Now, wildcard certificates are totally legit, and the certificate would have been accepted by SSL if if the wildcard only appeared in the subject of the certificate. But modern certificates don't put the hostname in the subject field anymore. They put it in the subject alternate name, which is an extension somewhere further down. It's not shown here. But the way Erlang OTP certificate verification works is if the subject alternate name extension is present, then it will use that and not the subject. And if it's using the subject alternate name extension, it doesn't by default accept wildcard certificates. And this is an interpretation of an RFC. The RFCs that specify the behavior of certificate verification, they are not very clear, and they are kind of protocol specific, so it's kind of different when you're talking HTTP versus MQTT or SMTP. And apparently the reading of the OTP team is that this is something that's HTTPS specific, and because the SSL options are generic, they should work for any protocol, you need to opt into that hostname, that wildcard the wildcard pattern matching. So there's an option for that. It's here. So customize hostname check, and there's a function in the public key module. You can write your own function if you want, but this is the one that comes with Erlang OTP, and it will use the HTTPS variant of the hostname matching. And the HTTPS variant will accept wildcard certificates in the subject alternate name extension. Okay, so with all these options that you see here, we now can make proper HTTPS calls to most servers on recent OTP versions. If you're on an older version, 20 or 19, then there are some additional issues that you need to be aware of, but I'm hoping most of you are on 21 at least. And I said with most servers because there are still some corner cases. For example, servers that use a cross-signed certificate. This is not handled very well by the OTP implementation. And another example is the OTP implementation is also very strict when it comes to the order in which the server presents its certificates. If you have a server that presents its intermediate certificates in the wrong order, or maybe has an extra certificate that maybe shouldn't be there, so OTP will say, this is invalid. Whereas most other implementations, they basically find the server certificate, the end certificate that has the hostname of the server, and then it will look for any kind of path that connects the server certificate through some intermediates that may be in the CA Trust Store or in the certificates that were delivered by the server, and then somehow trace it to a certificate in the CA Trust Store. So there are some cases where maybe your browser will accept a connection to a server and Erlang SSL won't, but for most servers, so I would argue that this is a server misconfiguration, but it's not always possible to get the server guys to reconfigure that. So proper HTTP with most servers. Okay, now some of you might be saying, okay, but HTTPC, I'm not using HTTPC. But remember what I said in the beginning, this applies almost universally. If you look at like just HTTP clients, most of these do not, now all of these on this slide, and maybe others that I'm not aware of, do not have secure defaults. Everything I just said about HTTPC applies to these clients as well. And it applies beyond HTTP as well. If you're using some other protocol client, or if you're using some client that runs on top of one of these, like an API client for Google Cloud or AWS that actually uses one of these HTTP clients under the hood, they may not have secure defaults. Now, some of you may say, I know that. That's why I use HTTPoison. Now, HTTPoison is the most popular HTTP client, at least in Elixir. And it's based on Hackney. And Hackney has these dependencies. The most interesting ones here are Certify, that's a CA Trust Store that we saw earlier, and SSL Verify Fun, which is an alternative implementation of the server certificate verification that actually handles wildcard certificates and a few other issues, even on older OTP versions that didn't support it properly in the first place. So that's a good start. So if we make a request again to first of all a valid server, the connection succeeds. And if we make a request to a server with a self-signed certificate, it fails. So we're good, right? Well, up to a point, because it's possible to shoot yourself in the foot also with HTTPoison and Hackney. Because if you pass in your own SSL options, for example, to harden the client and say, I only wanted to use TLS version 1.2, then Hackney basically says, you want to do your own SSL options? Go ahead. Good luck. And so here I am connecting to a server that has a self-signed certificate. I'm passing in this additional option, and my connection succeeds, which of course it shouldn't. Okay, now, vulnerabilities. Why are we talking about this in public? It's even recorded for YouTube. So, I mean, are they vulnerabilities? Or I would argue this. These are libraries. They work as advertised. They never claimed to have secure TLS defaults. They just use the SSL application, which comes with Erlang OTP. The Erlang OTP library made certain choices. Basically, it put the responsibility with the user. So, I mean, I don't consider these vulnerabilities. I think it's maybe just a misunderstanding that users might not be aware that they have this responsibility to bring a CA Trust Store. And I definitely don't want to diss the developers behind these libraries or the Erlang OTP team. They're doing an amazing job maintaining almost single-handedly TLS implementation. It's just, we need to be aware of these limitations. We need to be aware of what's expected from us when we're actually building an application using these tools, using these libraries. Because at the end of the day, the security requirements might be different from one project to another. So when we build an actual end-to-end project, we need to decide what do we want from our TLS connections, which CA certificates do we want to trust, how do we want hostname verification to work, maybe we want to be a bit more flexible. And we need to pass in those options, and yes, it's hard, it can be complicated. So having said all that, when people ask me which packages to use, I will definitely steer them in the direction of packages that do the right thing out of the box. So I just want to give a shout out to 2 packages that do the right thing. So Mint is one of them. It's the new HTTP client, I don't know, toolkit. It's not really a full-fledged HTTP client, but it's a kind of a toolkit for building one by Eric and Andrea. So it's still in progress, but it's the TLS defaults are there. And Tortoise, the MQTT library by Martin. So these are examples of libraries that not only do they have secure defaults, but also the documentation makes it clear what's expected from us as users of these applications. Okay, there's one more thing about clients before I will briefly talk about servers. Revocation check. Okay, certificates can be revoked, and they're basically, now some people would argue that certificate revocation is kind of broken for internet scale PKI, but it's better than nothing. Unfortunately, Erlang OTP only supports CRL, which is kind of the old-fashioned way of doing things. OCSP, the more modern and maybe better way to do it, is not yet supported. So that's one thing to be aware of. So here's a server endpoint that serves a revoked certificate, and these are the options you'd have to pass in order to make this connection fail. Now note the use of the SSL CRL cache module, which you might be forgiven for thinking it's a cache, but it's not. The line that actually would make it a cache is commented out with a note saying, we need to figure out how to purge the cache at some point. So basically this means that every single TLS handshake that you're performing will make another connection and make basically an HTTP request, typically over TCP, not over TLS, to the certificate authority in order to fetch the latest CRL. And when it's done evaluating the CRL, it will just be discarded, and next time you'll have to fetch it again. So this has a performance impact. But for security critical applications, this is how you do certificate revocation checks. Okay, now I've spent the last 19 how long have we been talking? 29 minutes about clients, and that leaves me only a few minutes to talk about servers. Now, luckily, there is the HTTPS guide. If you haven't seen it, it's under the plug project on HexDocs. And now, I would tell you this is an excellent document, but then again, I wrote most of it, so that would be blowing my own trumpet. But I like to think of this as something worth reading. This is the stuff that I would have been talking about if I had had more time to cover servers in this presentation. I just want to talk about a few specific tasks, specific points. By the way, because Phoenix is built on plug, so this applies to Phoenix as well. And of course, there's much of it is also applicable for other types of servers that you might be building. Okay, Cipher filtering. So there is an API in the SSL application for filtering based on some pattern. So, for example, in this case, we're taking the defaults, and then we're filtering by key exchange. We're saying that if we want only ciphers where the key exchange is ECDSA, ECDHE RSA, and only EAD ciphers. So this returns those 2 ciphers. Now, of course, in Elixir, there's maybe a more idiomatic way of doing it with enum.filter. So the important thing is you need to check if the result is empty, because if you get an empty list and you pass this into your SSL socket, the SSL application will fall back to the defaults. So this might lead to unexpected results and maybe weakened security. So make sure you check before you pass the value into the ciphers option. There's basically 4 ways to specify ciphers. One is as a map, which is what we have seen in the previous slide. One is as a tuple for backward compatibility with earlier versions of the SSL application. One is using character lists, okay, what Erlang would call strings. And one is using binaries, So this is an ID, a 16-bit ID from some RFC. And can you guess how this might backfire in Elixir? People sometimes pass in a list of Cipher names, the character list that you see here under number 3, but as a Elixir string. And then Erlang will say, you're using binaries. Elixir strings are binaries, but it doesn't match any of my 16-bit RFC IDs. So you're basically, it's filtered down to an empty list and you're falling back to defaults again. So remember, Elixir strings are binaries, they don't match any of the RFC IDs. Now, a few words about the certificate and key of a server. So one place where you might want to put your certificate or key is in the priv directory of your application. But remember, it becomes part of your release. It gets baked into the release. So if you want to renew it, you may have to push out a new release. The same thing we saw earlier when we were talking about CA certificates as a package. So it might be easier to just use an absolute path. For example, if you're using Let's Encrypt to get free certificates, so there's a global path where it will update the latest version of the certificate. It's a symbolic link, so if you renew the certificate, it gets switched out atomically. If you renew your certificate, there's no step 2. Again, you don't have to even restart your server because the SSL application will pick up the new PEM file automatically. So there's more about this in the plug HTTPS guide. Now you may want to protect your private key. You may not want to store it in plain text on the disk. That's usually a bad idea. So one way to handle this might be to fetch the private key from a Vault server, for example, and then not write it to disk, but pass it in memory to the SSL application. You would have to use their format, like the binary format, rather than the base64 encoded format. And for that, you use the key option rather than the key file option. But the downside is that it's harder to replace at runtime. So as an alternative, I can suggest using a password-protected PEM file. So the file actually does reside on disk, but it's encrypted and password-protected. And then you fetch the password from Vault. And the password you pass in memory. And that way, if you replace the private key, it gets picked up again automatically, as long as the password hasn't changed. Just remember to use AES 128 encryption until OTP 22, because the default of OpenSSL, well, there's not really a default in OpenSSL when you're generating key pairs, but people tend to pick AES 256 because it sounds better, and it's not supported by OTP at this time. In 22 it will be supported. Okay, I don't have time for this, I'm sorry. So if you're interested in ECDSA certificates, talk to me later. So wrapping up, I think there are 2 key takeaways. One is when you're using TLS, make sure you verify the behavior. Don't just test the positive path, the happy path. Make sure you verify also the negative paths. So don't just implement the functional requirements that you get from your product owner or whoever, also the security assumptions, because at the end of the day, the certificate verification, for example, that's what it's all about. It's like it's about the negative cases. The positive case, you can make it work with verify none, but really it's all about making sure things fail when they should. And check the documentation of the packages that you're using for security aspects. Now, there's room for improvement in a lot of packages. So for package authors, I would say spell out the user's responsibilities so that people know what's expected from them to stay secure. And before I go, I just want to thank my employer for letting me come here to talk to you and work on some of the open source and community projects. And again, my name is Bram. I sometimes blog, I sometimes tweet. Thank you.
I think we have a couple minutes for questions, if there are some.
thank you so much for the presentation. It was really interesting. So I have a question regarding HTTPoison. Not that I use it in production or anything, but I just wanted to ask. So it seemed, I don't know if I understood the problem correctly, but it seemed like the issue was that it will override the options completely.
Yes, so it doesn't like deep merge the SSL options.
Yeah, so that seems like it could be fairly something that you could do, at least like emit a warning, warn the user. Does it do any of that? Doesn't it? Or how would you approach improving it given that limitation?
Yeah, that's the tricky thing. I mean, in general, on this whole topic, not just about HTTPoison and Hackney, but also the OTP implementation itself. Like, can't we just like change some of the defaults? And of course, the problem is backward compatibility. You don't want to break running applications. On the other hand, maybe those running applications, if they fail after the upgrade, it's because they were insecure in the first place. But yeah, it's not trivial, especially. Like merging the SSL options, like Mint does, for example. There are corner cases because parameters depend on one another, so it's not easy. But yeah, a warning would be nice. But I think the lowest hanging fruit is the documentation. It should be spelled out so that people don't have these kind of surprises.
Okay, so talking about clients, why don't we just use OpenSSL like other languages?
Right. So we did once. So until a couple of releases ago, the OTP SSL implementation was also based on OpenSSL, and the issue at the time was that these NIF bindings, they were blocking the scheduler, and this was before dirty schedulers. So there were scalability or performance issues with like. Schedulers being blocked by OpenSSL. Now maybe it might be possible to go back to that model and use dirty schedulers. There also is an implementation as a package. It's called FastTLS that basically is exactly that, NIF bindings to OpenSSL. Yeah, there's something to be said for using OpenSSL. Just, it's the same. I get this question sometimes about servers, like should I put Nginx in front of my server or should I terminate TLS inside the beam? And I don't have an answer for that because either like the advantage of OpenSSL is that if everyone upgrades because of some vulnerability, you also upgrade and then you're done. On the other hand, the OpenSSL, because it's written in C, is susceptible to a certain type of issues that maybe Erlang is not susceptible to. For example, Heartbleed is unlikely to affect an implementation in Erlang because the way memory management works in the Erlang VM. So, yeah, there's no clear answer.
So, one last question.
Thanks. I have a question regarding the two concepts you explained. So the fact that session IDs are stored in production systems so that no additional handshake is required. And the other one is the CA store, where I now get automatically the updates. So if a certificate gets revoked and I have a previous session created with a client, so how do I deal with that? Or how is that solved?
So that's not handled. No, if the decision is made at the time of the TLS handshake, the original TLS handshake. So if you have an ongoing connection, or even you resume a connection later, the changes to the CA trust store are not considered. So normally session resumption only works within a short time frame. So the fact that maybe it takes a couple of minutes or hours for the CA updates to propagate through your application is usually acceptable. Certificate revocation also doesn't work with milliseconds updates. So I don't think it's a major issue. But yeah, it's something to be aware of, especially if you have long-lived connections that might. Now, if in theory you could go over long-lived connections and say, oh, this connection was established before this CA certificate was revoked, and now I need to close it.
Yep. Thank you, Bram.
Okay.
Applause.